Okay, welcome to day 2 of general chemistry. So we left off with the SI base units, and as I said, you need to understand that mass is kilograms or grams, length is meters, time is second, temperature is Kelvin, amount of a substance is moles. We're not worried about the other ones. The reason why you need these unit abbreviations is because that lets you know what the problem is talking about. For example, if we wanted to we're going to talk today about density. If you want to calculate the density of a molecule, density equals mass over volume. And that's a formula you'll need to memorize. You can make a heart here and just put a line through that, and you can see that this is an M and this is a V. Okay, so there's a kind of catchy way to memorize that. So if you were given a problem like what is the density of a substance that has a that is 400.56 grams and displaces an amount of water 2.54 milliliters. Okay, so then you would need to recognize that G is mass. So then you would know to put that on top, 4.56 grams, and then you would need to know milliliter is, oh, we don't have volume on there. Well, you definitely need volume on there. Volume should be milliliter or liter, so include that. So that is volume. So then you would divide by 2.54 milliliters. And if you get your calculator out, you would do 4.56 divided by 2.54. That gives you density equals 1.795 grams per milliliter. And we'll also learn that significant figures. You'll notice that this is division. And so when we do division and multiplication, you have to report your least number of significant figures in your math problem. Significant means important, and we'll go into depth more about what that really means. So you can see that the top has 3 significant figures, and I'll just write that as SF. And the bottom has 3 significant figures. So the least number of significant figures is 3, because it's 3 versus 3. So here we have 1.7. So now we have to decide what to do with the 9. Okay? Is it going to be 1.79 grams per milliliter, or is this going to be we round that up to 80 grams per milliliter? And because this 5 here is the next digit that you look at, the 5 rounds the 9 up. So the correct answer is 1.80 grams per milliliter. So this is why you need to know what the units are for a measurement so you can apply formulas and do different kinds of calculations in chemistry. All right, so which of the following statements is correct? Mass is measured in grams. Very good. Okay, so we left off here with the SI units, and what's important here is kilo and mega. Now you might have to use all of these for your homework, but these are just kind of what I would give you on an in-class exam or on your online quiz, anything that I write. So this is your base unit. So the way I do this is let's just make this a gram. Okay, so we're saying the gram. Everything above this base unit is bigger than the base unit. And everything below is smaller. And so these are your prefixes. And you see your prefixes, so you can have a megagram or you can have a kilogram. You could have over here, you can see you could have a decigram, you could have a centigram, you could have a milligram, you could have a micro. That's like a squirrely cursive U, microgram, nanogram, or picogram. And so these prefixes have meaning. So when you think of deca, think of decade, right? So deca I just think of is 10. Centa, I think of century. Century is 100, like 100 years. Milla is 1,000. Now notice we're going to increase by 3 zeros now. Micro means 1 is 6 zeros. Nana is 9 zeros. Pica is 12 zeros. You have to memorize these. We're going to do conversion factors. CF. Okay, you'll see me say CF, conversion factor. That means these things equal each other. So you already know conversion factors. 100 pennies equal $1. That means for every 100 pennies, that is the same thing as $1. Now I want you to notice that this is a big number. This is a small unit. What's bigger, 100 or 1? Hundreds, that's your big number. What's smaller, pennies or dollar? Pennies. So the big number always goes with the small unit, okay? You cannot say 1 penny equals $100. You all would laugh at that, right? You would say, of course that isn't correct, okay? So that's why it's important to get these conversion factors. I just need you to write conversion factors, the ones that equal each other. So kilo means 1,000, mega means 1 and 6 zeros. So there's 6 zeros, there's 3 zeros. So you can see. So if we have nanogram and gram, okay, so the prefix N means nano. Nano means 1 and 9 zeros. Okay, so this is what it means. Now, which is the, so you're going to get, one of these is going to get a 1, and the other one's going to get the 1 billion. Which one's bigger, 1 or 1 billion? Right, so this is your bigger number. And what is your bigger unit? This is your bigger unit. So bigger number, bigger unit. So we don't want to do big with big. We want to do a big number with the smaller unit, because see, everything here is smaller than the base unit. And then the 1 would go with gram. And that's the same thing as pennies and a dollar. And so you need to be able to write these conversion factors. These conversion factors I do not require you to memorize, so I will provide them for you, but you will maybe need to have this chart and refer back to it to work your homework and quizzes and stuff like that. Okay, so before we leave this, I want you to convert. Let's do 29.5 microliters into liter. And so I need you to do dimensional analysis. You might have learned a way to do this, but if you do it this way, you learn this way, when we start getting into balancing equations and doing math for chemistry, then you already have this skill. This is a skill. It's like driving a car or balancing a basketball. You have to practice the skill. So in dimensional analysis, you start, step 1, you start with the given over 1, over the number 1. So how do you know the given? The given is always going to be a number with a unit in your word problem. So do you see that 29.5 is a number with a unit. So that's where you're going to start. 29.5 microliter over 1, and then we're going to do these railroad tracks. Now step 2, you copy the unit from the given on bottom in your second box. Okay, so you see how you have microliter? You just copy down microliter. And then you want to go from microliter to liter. Now, the question you have to have, do you have a conversion factor that can say how many microliters equal a liter? Or how many liters equal a microliter? This is where you had to memorize it. So what's micro mean? Micro is 6 zeros. And is micro big or small? Okay, it's smaller. So the big number is going to go with the small unit. So this is your conversion factor. So you have 1 million microliters for 1 liter. And now you can come down here and you can put the 1 million with the micro and 1 with the liter. And now you can get your periodic table out, and or not your periodic, your calculator. You multiply the top numbers. You divide the bottom. So you could do 29.5 times 1. That's just going to give you 29.5. Okay, so then you type in 29.5 and you divide that by 1 with 6 zeros. And that gives you 0.0000295. You see these units cancel each other out, so that's liters. 1, 2, 3, 4. And I will teach you how to convert that into scientific notation and also how many significant figures there are in that problem. So we're going to work towards that way, but you see how you need to start practicing converting these SI units into other SI units. Okay, this is showing you density. Density is, well, this is volume. Volume is length times height times width. And this is showing you laboratory volumetric glassware that does volume. This is showing you just different pictorial of mass versus volume versus length. Okay. So, everything in science has a number and a unit. And so they're showing you here, this is area. So the area of a square is length times width. So the length times the width is the area of a square. Okay, so length times width is the area in this space here. So if you have something that's 3 feet and this is 4 feet, then 3 feet by 4 feet equal 3 times 4 is 12, but then you also have to do the same thing with the unit. Feet times feet is feet squared. Here, you would, this is reducing terms. This is division, so you could get the line means you divide. So when you take 350 divided by 7, that becomes 50 and that becomes 1. And so if you want to get this, you can write this as 50 mile per hour. You can see it like that. Or you can keep it on the same and do -1. That's the same thing as mile. And then you can take that bottom unit to the -1. So that's just kind of nomenclature, how to work with units. Okay, so I introduced a conversion factor. You're going to have to come up with conversion factors. This is like 100 pennies equal $1. It's like 12 eggs equal 1 dozen. They equal each other, okay? And so there are 5,280 feet in 1 mile. So that equals 1. So you can say 5,280 feet in 1 mile. You can switch them around. That equals 1. Here you can have 100 pennies in $1. That's okay. That equals 1. Or you could say $1 and put that on top over 100 pennies. Equals 1. You can say 10 decimeters are in 1 meter. That equals 1. Okay? Because remember, deci is small and deci means 10. So we need those conversion factors in order to convert one unit into another. Okay, so a conversion factor is chosen and set up so all units cancel except for those required for the answer. So remember, I told you that you want to start step 1, because this is how to convert. This is dimensional analysis. This is how to do dimensional analysis. So the start step, you start with a given, and you're going to put it over 1, and then whatever that unit is, you're going to copy on the bottom, and then each one of these brackets. Now you're going to get to where you might have like a bunch of these brackets, because you'll be taking one unit to another unit. So we can call this the given. You can say this is unit A, and then we can go to unit B, and then you'd have to copy unit B down here, and then you could go to unit C, and then you'd have to copy unit C down here to go to unit D. And then you'd have to copy unit D down here because you don't want that to go to maybe to unit E. And then what happens is these cancel out. Unit A cancels out, unit B cancels out, unit C cancels out, unit D cancels out, and then you're left with one, unit E. So this is how you convert one unit to another unit. And now each one of these blocks here has to have a conversion factor, and conversion factors always equal 1. Okay? And so those are the ones that we'll call putting in your toolbox. And they equal each other. So let's read the problem and see what we can do. The problem. The height of Angel Falls is 3,212 feet. Express this quantity in miles. Okay? That is your given. Do you see? That is a unit, a number with a unit, okay, a measurement, feet. It is by itself. Now this equals each other. This is a conversion factor. This is a conversion factor. This is your given. That's where you start. So you would start with 3,212 feet, and you would put that over 1, and then you would put the unit down there. And then you'd say, okay, what's my question? Express this quantity in miles. So can I go, so that's your question. So the question you want to ask yourself, can I go from mile or from feet to miles? Because you're at feet to miles. You see how these are equal to each other? Yes, you can go from feet to mile. And for 1, make sure the 1 goes with mile, and 5,280 goes with feet. Okay, so that means those equal 1. Now, feet will cancel out because they're on top and bottom, and you're left with mile. So now you know that you have to divide 3,212 divided by 5,280. And so that's going to be 0.608 mile. And so we have 4. So let's add another one there. 4 significant figures. So that is your answer. Just like you can see that here. So the plan is, when you clarify the known and the unknown, we call that the given. So the given is where you start. It's going to be a number with a unit, and you're going to put that over 1. That'll be your number, and then that unit will go here. Then the question is unknown. You need to figure out what is the unit you need. What are you trying to get to? And then you need to come up with conversion factors. These are units that equal each other. And then you can figure the steps. Okay, so let's read the problem. To wire your stereo equipment, you need 325 centimeters of speaker wire that sells for 15 cents per feet. What is the price of the wire? Okay, so remember, the first thing you want to do is start with your given, and the given is a number with a unit. So you have two numbers here. You have this number, and then you see another number. Do you see that this is a conversion factor? Do you see you have two different units? You have $0.15 equals 1 foot. If you don't have a number in front of there, that's a 1. And that mark here, that slash, is equal. So that's your conversion factor. That is not a given because those are two units. The dollar sign is a unit. Okay? Feet is a unit. So that means you are starting with 325, and this is centimeters, cm. So that's your given. You start with 325 cm, and then you put cm on the bottom. Now, do you have a conversion factor? You want price, so you want to be left with dollar signs on top. Okay, we can go from, this is our plan, our conversion factor plan. We can go from centimeter to something, but and then somehow we need to go from feet to dollars. You see how we can do feet to dollars? We can do feet to dollars because we have this conversion factor. But how do we get from centimeters to feet? That's where you need other conversion factors, and you would look at that sheet and you could say, okay, two other conversion factors, 2.54 centimeters equal 1 inch. Like I said, you don't have to memorize these. I would give you a list of conversion factors, but you'd have to find them and come up with the plan. The plan's hard. You got to come up with the plan. And then you can go from inches, 12 inches equals 1 feet. Okay, so that would get you there. A lot of times I try to do it like, okay, so here we got centimeters. We're at centimeters. And then we can go from centimeters. It's kind of like, look at that. Okay, we can go centimeters to inches, and then we can go from inches to feet. So as long as I can connect these, then it's a path. It's a plan. Okay, so now we have to go from centimeters, and don't worry about your numbers. You can fill those in at the end. You just need to go from centimeters to inches, and then you got to have another railroad track. We don't want inches, so you're going to copy that on bottom, and then inches to feet. We don't want feet, we want dollar signs. We have this one here, so we're going to put feet on the bottom, and then we'll put dollar sign. Now you can go back in and put in the numbers. So for centimeter, we have 2.54 goes with centimeter. You want to make sure that you don't have this in reverse order, or it'll be wrong. And then we have 12 goes with inches, and 1 goes with foot, and then we have 1 goes with foot, and 0.15 goes with dollar sign. Now, you can get your calculator out and go 325. You can multiply by 1. Well, it's going to be 1. Divide by, we just go from left to right, divide by 2.54. I hit an equal sign. And then I'm going to take that number, divide by 12. And then I'm going to take that and times by 0.15. And then I get an answer that's 1.59940,945 dollar sign. And now we'll talk about significant figures, But these conversion factors that equal 1, you don't have to worry about those. They're considered the number of significant figures, and those are considered infinite. You know the infinity sign, because conversion factors are exact numbers. There's no doubt. There's no doubt. They're infinite confidence. So the only number that determines, and this is multiplication and division, okay? And so the only number that determines how many numbers of significant figures you report this to is in your given. So we'll show you how to figure out significant figures, but every number gets counted. There's 3 significant figures in that given. So this is going to have to get rounded to 1 point. We're going to have to round this one because we want 3. So we've got to take a look at this number here. This is a 9. 9 is greater than or equal to 5, so we're going to have to round up. So this is going to be $1.60. So the cost of the wire is going to be $1.60. And that is exactly what you see here. You can see the solution. Okay, so let's work another problem. A graduated cylinder contains 19.9 milliliters of water. So I'm going to draw a graduated cylinder that you might see in the lab. And it has water in it. And that measurement is 19.9 milliliters. That's volume. When a small piece of galena, an ore of lead, is added, it sinks. Okay, so then we're going to add a piece of lead here, and it sinks, and now the volume increases to 24.5 milliliters. So the question is, what is the volume of the piece of galena in centimeters cubed and in liters? Okay, so when you want to know the volume of this red piece of ore, this is actually called volume displacement. It is a technique done in the laboratory to calculate the volume of the metal by water displacement. So what you do is you want to take the difference. So this is the difference. You take 24.5 and you subtract 19.5. 24.5 minus 19.9 milliliters. So the volume is 4.6, and see how those are, yeah, so 4.6 milliliters. And so that is your volume in milliliters, but it wants the volume in centimeters cubed. So that's your given, 4.6 milliliters over 1, and then you copy milliliter down here. Now you need some conversion factors. So I'm going to give you a conversion factor that I do think you should memorize. 1 milliliter equals 1 centimeter cubed. Okay, so the same is because if you took a milliliter by a milliliter by a milliliter, I mean a centimeter by a centimeter by a centimeter cubed, then if you filled that cube up with water, it would be 1 milliliter. Okay, so you can go from milliliter to centimeter cubed, and then you just put a 1 and 1, so that's going to be 4.6 times 1. The milliliters cancel out, so this is 4.6 centimeters cubed. And then it says, what is this in liters? So let's do another one, 4.6 milliliters, that's your given. You put milliliter on bottom. Can you go from milliliter to liter? This is a conversion factor you should have memorized. Okay, so let's do it. Is milli, is that big or small? That's small. Okay, so it's a smaller unit. And what's milli mean? 1,000. So 1,000 milliliters equal 1 liter, because the big number goes with the smaller unit. So now you make sure you have 1,000 with milli and 1 with liter. Now you know that you want to divide, because it's on bottom. 4.6 divided by 1,000. That gives you 0.0046 milliliters cancel out, and you're left with liter. All right. And you see, I avoid this whole negative to the 3 thing by doing my conversion factors this way. All right, so this is showing you the solution. Volume by difference, they subtract that, that gives you the volume, and then you can convert it using these conversion factors. And you see, this is scientific notation, so the negative means that you have to make the number smaller. Okay, negative exponent means the number smaller, so we got to move that decimal 3 places. So 1, 2, so 1, 2, 3. All right, we have another example problem, converting units of mass. So let's read our problem, find out what our given is. Many international computer communications are carried out by optical fibers and cables laid along the ocean floor. If one strand of optical fiber weighs 1.19 times 10 to the negative third pound per meter, what is the mass in kilograms of a cable of 6 strands of optical fiber, each long enough to link New York and Paris? Okay, so do you see that this is a conversion factor because there's 2 units? And I'm going to take it out of this exponent, okay? So that's a negative, so that's 0, 0, 1, 1, 9. So we moved it 3 places. 1, 2, 3, and this is pound, equals 1 meter. Okay, now the number in the unit here is 6. 6 strands. So 6, and we can just call strands of optical fiber, so 6 strands is your given. You put that over 1, and then we're going to write strands on bottom. Okay, so they're telling me how long each, what is the mass? Okay, so the question is mass. We want kilograms of a cable made of 6 strands of optical fiber. Each strand is long enough to link New York, Paris. So each strand, so we need to write a new conversion factor. 1 strand equals 8.94 times 10 to the third kilometer. So let's get this out of scientific notation. 8940. Do you see that this is now a positive exponent? So we got to make that number bigger. So we got to move it 3 places. 940. So that is kilometers. So that's 1 strand equals 8940 kilometers. And so now we're going to do our plan. Okay, so we are on strand. We can go from strand to kilometer. Okay, and then do you see we got a meter here? We can go, can we go from kilometer to meter? Yes, we memorized that, right? Those are the SI units, or the base conversions. And then we can go meter to pound. And what's it asking for? It wants kilograms. Okay, that's where you're going to look at your other list of conversions, and you can go from meter to pound. So let's write that down. So 1 meter equals 0.0. Oh, this is what I want. We can go from pound to kilogram, and you would look at your sheet and you can see that you can go from pound to kilogram with that conversion factor. So now we just have to do that. So for strand to kilometer, and remember, you just put in your units. We don't want kilometer, so we put that on bottom. We can go from kilometer to meter. We don't want meter, so you put that on bottom. We can go from meter to pound. We don't want that. We go from pound to kilogram. So now we just have to plug in the numbers, because you see strand cancels, kilometer cancels, meter cancels, pound cancels, and we're left with kilogram. So what's our, for 1 strand, we have 8940 kilometer. Okay, so you remember this one, kilometer and meter? So kilo means 1,000, and it's a big number, big unit. So for 1 kilogram, we have 1,000 grams, because grams is the smaller unit. It gets the big number. So, well, in this case, we want meters. Okay, so 1, small number with big unit, 1,000 meters. And then we have here 1 meter goes with meter, and pound is 0.00119. And then here we look at a chart and we see that we have 2.205 pound for 1 kilogram. So now you do 6 times 8940 times 1,000 times 0.00119 divided by 2.205. And that gives 28,948.57 kilogram. And the question is, did I answer the question and did I do it? The math correct? Let's see. 28,940. Did I do the math wrong? No, that's right. 89. So here it's weird because one string. So here it's showing you the solution to pound. We did. And then, yeah, so if you make that number bigger, you got to move the decimal 4 places to make it bigger, because that's a positive exponent, 8600 kilograms. So let me go back and see. 2,000. Oh, so I might have done some math wrong. 6 strands, I mean, what, you have 1 significant figure? So yes, that's why they rounded it for 3. So that's good. All right. This one is, what if you're raising something to the power? Okay, so let's break the problem down. You see how it's helpful to figure the given and the conversion factors? A furniture factory needs this much fabric to upholster 1 chair. Its Dutch supplier sends the fabric in bolts that hold exactly 200 meters squared. How many chairs can be upholstered with 3 bolts of fabric? Okay, now, even though this seems like that is a number with a unit, it's really 31.5 feet squared of fabric to upholster 1 chair. So that equals 1 chair. You see how that's a conversion factor? Its Dutch supplier sends the fabrics in bolts that hold, so 1 bolt equals 200 meters squared. How many chairs, so this is your question. Sometimes I like to circle the question. Okay, so how many chairs, so we want chair to be the end, can be upholstered with 3 bolts of fabric? This is your given. This is where you start. Okay, because that's your number. So you want 3 bolts, and you're going to put that over 1, and then you put bolt on bottom. Okay, so now we can go from, this is our plan, we can go from bolt to meter squared, right? But then we need to go, so we can go from bolt to meter squared, but then we need to go somewhere to get to feet squared to get to chair, because we can go from feet to chair. But how do we go from meter squared to feet? Well, you can look, and there is a, on that list, you can see that 0.3048 meter equals 1 foot. Okay? Now, but we're dealing with meter squared and feet squared. So what you have to do when you get a conversion factor like this is you have to square the number, and you also have to square the unit. Sometimes you cube these things. So that's what they're doing here. So you're going to need to take 0.3048 times 0.3048 to get the number 0.0929. So that's the squared, and then that's meters squared. And here, 1, what's 1 times 1? That still is 1 feet squared. So this is the conversion factor that you need right there. All right, so now when you're starting this, you can go from volt to meter squared. You don't want meter squared, so you put that on bottom. Meter squared to feet squared. And then you can go, you don't want that, so you put that on bottom, to chair. And now you can put your numbers in. So here, 1 goes with volt, 200 goes with meter squared. Here we did this one, it's 0.0929 meters squared for 1 foot squared. And here we have 1.5 feet squared for 1 chair. And what you'll notice is volt cancels out, meters squared cancels out, feet squared cancels out, and we're left with chair. So get out your calculator and do 3 times 200 divided by 0.0929, and then divide by 1.5. And so did you get 205 chairs? Okay, so let's see. 205 chairs. There you go. All right, so why don't you try this? Convert 5.6 ounces into teaspoons. And then so here you have like conversion factors. So you might get something like that from me. You're given is 5.6 ounces. And then you got to have your plan. We want to end up with teaspoon, TSP. That's a tablespoon. This is teaspoon. Okay, so we want to end up here. Is that the only conversion factor? Yes. So, and we're on ounces. So we are here. So you see how you can go from ounces to tablespoon, TB, and then you go from tablespoon to teaspoon. So then what you do here is you convert the ounces here because you have OZ there, and you can go from ounces to tablespoon. You don't want that, so you put that there, and you can go from that to teaspoon. And then you put your numbers in. So here 1 goes with ounce, 2 goes with tablespoon, 1 goes here, 3 goes there, and then you use your calculator, 5.6 times 2 times 3. And did you get A? 33.6 teaspoons. You see how these cancel out, and you're left with TSP. Okay, we talked about density. Density equals mass over volume. You need to memorize that. That's your first formula. Might want to just, on your back of your periodic table, start keeping a formula sheet, okay? Now, usually the temperature and pressure is considered constant, and what does this mean? That's a characteristic physical property. That means the density of water at a certain temperature and pressure is going to be 1 grams per milliliter, or 1 gram per 1 centimeter cubed, because remember centimeter cubed and milliliter are the same. 1 centimeter cubed equals 1 milliliter. Sometimes you'll see density like that. That means water, if it's characteristic, it's always that way. Like I have brown eyes. That's characteristic of who I am. Okay, so it doesn't matter if I'm in the dark. It doesn't matter if I'm in Alaska. It doesn't matter if I'm Florida. It doesn't matter where I am. That is characteristic. I got the brown eyes. Okay, and so density is something that's characteristic to that substance. In fact, this is how people decided gold when they would go and do the gold digging. You had the fool's gold, and then you had real gold. And so the way they would tell whether it was fool's gold or real gold, they would get a volume, they would mass it. So you'd get your weight balance out, and you put your gold on there, and then you would get the mass of the gold. Okay, so here's your gold nugget, and you get a mass, you know, like 2.50 grams. And then you'd put it in the graduated cylinder, and you do the water displacement. So you figure out what the water is before, you put your gold nugget in there, the water rises, okay, you take another reading, you subtract these numbers, okay, that's going to give you a volume. And then you can take the grams that you measured divided by the volume, that's going to give you your density. And that would determine whether you had fool's gold or real gold, because real gold, that's characteristic of gold. This is some common substances here. Solid gold, that's very high, 19.3 grams per centimeter cubed. Remember, that's the same thing as milliliter. Let's look at water. Water, we just go ahead and round that off to 1 gram per milliliter. You'll see me do milliliter. Aluminum is kind of low, 2.70. You don't have to memorize these. That's all right, so let's work a problem. Lithium, soft gray solid with its lowest density of any metal. It's actually in batteries. So here we have a mass, 1.49 times 10 to the third milligrams. And this piece of lithium has sides that are, now volume is length times width times height. So we're going to have to do this. So it has sides that are 20.9 millimeter by 11.1 millimeter by 11.9 millimeter. So we're going to have to get our calculator out and find out that volume. 20.9 times 11.1 times 11.9. That should give you a volume 2760.681. If you have millimeter times millimeter times millimeter, that's millimeter cubed. Okay? Find the density in grams per centimeter. Well, we're going to have to convert millimeter into centimeter. And then we can do the cubed. So what's millimeter and centimeter? Well, milli means 1,000. And it's small. And centa means 100, and it's small. So let's do some conversion factors. So 1,000 millimeters equal 1 meter. And then 100 centimeters equal 1 meter. So if we wanted to convert this, 2760.681 millimeter cubed, and I want millimeter cubed here, I'm going to have to go to meter cubed. I always go to the base unit, and then I'm going to go meter cubed into centimeter cubed. Now, so that'll get me into centimeter cubed. Now what do I do with the number? Well, we have this millimeter into meter. So if I want to make this cubed and make that cubed, I got to do 1 cubed, and I got to do this one cubed. And so now I got to do, with my calculator, 1,000 times 1,000 times 1,000. So we're going to have 9 zeros here, okay? And that'll get a 1. Then we have to do the same thing here. If we want this cubed and that cubed, the 1 has to be cubed. 1 times 1 times 1 is 1. And what's 100? 100 times 100 times 100. There'll be 6 zeros. Okay? Now we can take 2760.681. We can divide that by 1 with 9 zeros. And then we can multiply that with 1 with 6 zeros. And that gives you 27.60681 centimeters cubed. So, what is the volume So we just figured out the size. Find the density of lithium in grams per centimeters cubed. Well, we also got to convert milligram into gram. So 1.49 times 10 to the third milligram equal gram. Well, I mean, you got to do it like this: milligram on bottom and gram. So what's 1,000 milligram equal 1 gram? So now we're going to divide that by 1490 divided by 1,000. So that's 1.49 gram. So now you can, I'm running out of space here, the density is 1.49 gram divided by 27.60681 centimeter cubed. So you take the 1.49, you divide by 27.60681, and the density for A, part A, is 0.05397 grams per centimeter cubed. What is the volume in milliliters of a piece of lithium with a mass of 895 milligrams? Well, this is what you want to do then, folks. This is your number with a unit. So 895 milligrams over 1 milligram on bottom. And you want to go, what's our plan? You go from gram, so you go from milligram to, now you're going to use this density as a conversion factor, okay? So we can go from grams to centimeter cubed, and then centimeter cubed to milliliter. Because remember, 1 centimeter cubed equals 1 milliliter. So that's a conversion factor. So we can go from milligram to gram, and then we can go from gram to centimeter because density is a conversion factor. Gram on bottom, centimeter cubed on top, and then centimeter cubed on bottom, milliliter. And so now you want to put in the numbers. For milligram, there's 1,000 milligrams for 1 gram. For this one, you put in the bottom number 0.05397. For 1, that's 1. It doesn't have a number by it, 1 centimeter. And for 1 centimeter cubed, you get 1 milliliter. So to answer B, you're going to take 895 divided by 1,000, and then that's going to be divided by this number here, 0.05397. Okay, divided by 0.05397, and then that is times 1. So 16.58 milliliter. What did we say A was? Oh, well, obviously here, 0.0539. So we, let me just see this real quick. 895 divided by 1,000 milligrams into grams, and then that's divided by 0.05397. 16.5. We had an extra 0 here. So probably and so this is the plan. You can look at that and see if it follows the same plan as us. We've got some calculations, and 0.54 grams. Let's see, is that what we got? And so that's just rounded. Okay, so that's the density, and then they're going to use that density as an error from too many zeros at the earlier one. So you can find that error I apologize, I'm off by a place. Conversion factor. So here for 1 gram, and so 1.66 milliliters. Huh. Um, oh, well, 895 milligrams. So 895 divided by 1,000. So that gives you, we got that. And then, oh, so there, I think this is an error. See, that's 0.054. But I'm not going to spend the time to find it right now. Okay, so this is an example of that problem where the density of gold is 19.3 grams, and then you make that a conversion factor equal 1 centimeter cubed. And so here's your starting 5.98 grams. You put grams on bottom because that's a number with a unit. And then given the density, calculate the volume. So we want to go from gram to centimeters. So then you can do 19.3 and 1. And so 5.98 divided by 19.3, you should get 30.98, and that should be centimeters cubed. Um, oh, I'm sorry, it's been a long day. I think I entered this wrong. 5.98 divided by 19.3. So I didn't do division. 0.3098 centimeters cubed. So this rounds to here. That's a rounding. C. Okay, we're going to wrap up this lecture today with just temperature. Start practicing doing conversion factor problems. Work the problems in your textbook because, like I said, 50% of your exam 1 questions will come from those textbook problems. Okay, so temperature. Temperature is something that only exists if there's a difference. Okay, like temperature is just a movement. It's a measurement of movement. So you usually measure temperature by what? A thermometer, right? And the thermometer, the old thermometers had like mercury. Okay, so mercury is this Hg on the periodic table, and it's a liquid metal. Okay, and so what happens is when it gets really hot, then it spreads out. You know, the mercury moves away from each other, and the volume increases. Okay, and so then when it increases, it moves up the thermometer, and then you can measure that, and that's like an increase in temperature, and it might be 50 degrees Celsius. So it's absorbing the heat energy. It's absorbing the heat energy in the substance to make it expand. And so thermometers measure temperature. Heat flows from one object towards the object that has flows from an object with a higher temperature to a lower temperature. This is a new word. It wants to reach equilibrium. It's a chemistry word. And equilibrium means the same. It wants to get the same. So if you have this object here, so if you put a piece of metal, like, okay, let's say this is a hot piece of metal. This is a hot piece of metal. And you put it in a cup of cold water. So you put it in cold water and you let it set. Okay? Eventually, the hot metal is going to cool down and the cold water is going to become hot water. So the heat, the energy, the heat energy, the kinetic energy is going from the hot metal to the cold to get the same temperature. So for measurements, we're not going to worry about Fahrenheit. but I do want you to go from Kelvin to Celsius. Okay, so anytime you do that, if you have degrees Celsius, you just add 273 Kelvin. If you have Kelvin, then you're going to minus 273 degrees to get to Celsius. So here's some examples of Kelvin. Absolute zero here. This break means that this isn't an accurate representation. Um, Here we have melting point of water is 273 Kelvin, so there's your 0 degrees Celsius. Boiling point of water is 373 Kelvin, so that's 100 degrees Celsius. So a lot of the temperature scales were set on water. So the boiling of water and then the freezing point of water. Now the problem with the Celsius and Fahrenheit is we need to have a positive number only, positive numbers only scale, and that's where Kelvin came in, because some equations can't do a negative temperature. So there's your 273.15. Like I said, I really want you to be able to go from Kelvin to degrees Celsius and Celsius to Kelvin. You don't have to do Fahrenheit unless it's on your homework, and then you can look up how to convert that. These are some temperature scales here to kind of give you an idea about the freezing point of water and then boiling point of water. Absolute temperature is 0 K. So here, a child has a body temperature. Does the child have a fever? What is the child's temperature in Kelvin? I just want you to be able to go 38.7 degrees Celsius plus 273 Kelvin. So could you do that? 38.7 plus 273. Could you do 311.7 Kelvin? See, I don't do the 0.15, so it might not be as, I just expect 273. Okay, that wraps up today's lesson.